Good morning, students. Today we have to see about the alpha decay. So what is the alpha decay? A nuclear reaction in which an unstable parent nucleus emits an alpha particle and forms stable daughter nuclei is called alpha decay. Alpha decay, I told, it is nothing but helium nuclei, He24. And a decay of uranium U35 to thorium. It has become 234. So 238 to 234. So uranium 238 to thorium 234 with the emission of an alpha particle. So uranium 238 92. So on disintegration, because it's an unstable compound, so it is a disintegrate to thorium 234 90 plus helium 42 alpha decay. Because if you add this 234 plus 4 become 238 and 90 plus 2 become 92. So if the alpha decay is very easy to write, but you should know the element properly. That is the thorium 234 90 plus helium. So the helium nuclei in disintegrate means that is alpha decay. In a decay, the parent nucleus emits an alpha particle, and so it is clear that for the daughter nucleus, the mass number alpha decay for the parent is this 238. For the daughter nuclei, the 4 because this is a He4, so 4 mass number will be decreases. So the mass number decreases by 4 and the atomic number also decreases by 2. So here U238 gives He42 and thorium 234 90, because 2 is the atomic number, reduces means from 92 it become 90. And for 238 4 mass number is decreases means 238 minus 4 is equal to 234. And so beta decay, a nuclear reaction in which an unstable parent nucleus emits a beta particle and forms a stable daughter nuclei is called the beta decay. So beta decay is nothing but electron, E0 minus 1. So in this itself we can know, because there is no change in the mass number, but the atomic number will be decreases by 1. So in beta decay there is no change in the mass number of the daughter nucleus, but the atomic number, because minus of minus 16 minus 1 we will write, no. So 16 minus 1, because we are minusing it. So minus of minus 1 become plus. So increases of atomic number will be taken place. So beta that is phosphorus 3215 gives sulfur 32, because no change in the atomic mass number, but one number of the atomic number is increases 16 plus electron 0 minus 1. This is a beta decay. Note, in a nuclear reaction, the element formed as the product nucleus is identified by the atomic number of the resulting nucleus and not by its mass number. So in nuclear reaction, the element formed as a product nucleus is identified by atomic number of the resulting nucleus. So because here the atomic number only changing, here 2 changes, here 1 is increases. So we have to see only the atomic number of the resultant nucleus and not by its mass number. Next one is the gamma decay. In a gamma decay, only the energy level of the nucleus changes, because neutral, gamma rays I told neutral, because it is not having a positive or negative any charges. So in a gamma decay, only the energy level of the nucleus changes. The atomic number and mass number of the radioactive nucleus remains the same. There is no alteration in mass number and atomic number. Next one is the nuclear fission. So what is a nuclear fission? In 1939, German scientist Otto Hahn and F. Strassmann discovered that when a uranium nucleus is bombarded with a neutron, it breaks up into the smaller nuclei for comparable mass along with the emission of few neutrons and energy. So In 1939, German scientist Otto Hahn and F. Strassmann, this names and all you should know, in one word you will get, discovered that when a uranium nucleus is bombarded with the neutron, it breaks up into two smaller nuclei of comparable mass along the emission of few neutrons and energy. This process of breaking, that is breaking means splitting up of a heavy nucleus into heavy nucleus. Splitting up of, this is the nuclear fission. Splitting up of heavy nucleus into two smaller nuclei with the release of large amount of energy and a few neutron is called the nuclear fission. So, the splitting up of heavy nucleus into two smaller nuclei with the release of large amount of energy and few neutrons is called the nuclear fission. Nuclear fission of uranium-235. But here we saw uranium-238 because I told it is a this parent nucleus, this is the parent nuclei, this will decay because it is unstable. But this uranium-235 92 is a stable, is bombarded with the neutron N10, one neutron only. It gives barium and krypton. So barium is 14156 plus krypton 9236. If you add these two, 235 plus 1, 236, so 35 and 92 and neutron N1, barium 14156 plus krypton 9236 plus 3 neutron. 3 means here 3 will come. 3, 92 plus 3, 95, 96, so we'll get 236. Altogether 236, here also we got 236. Here 92, 56 plus 36. 56 plus 36, 92. So this 92 we get here because it's 0. So the average energy released in each fission process is about 3.2 into 10 power minus 11 joules. So nuclear fission, because one neutron is bombarded with the uranium nuclei, it gives the barium and the krypton and the 3 neutrons. This is known as the nuclear fission. Read it and write as a test and send me in the WhatsApp. Thank you.